Hey everyone, welcome back. This is week 2 of the rock cycle. We're going to be talking about sedimentary rocks today. Last week we talked about igneous rocks and how they're born from the lava and from the earth. And sedimentary rocks are usually considered to be like a second level of the rock's life cycle. Obviously doesn't always the case because they can switch between different forms. But normally, yeah. Because, I mean, it's still called a cycle even though it's not really a cycle. And to understand sedimentary rocks, we need to know what sediments are. Sediments are when weathering and erosion occurs. We talked about this before with that video, and we had a little worksheet with it. Weathering and erosion. Weathering is when the wind chips off teeny bits of rock from rock formations, and erosion is when water does it. Well, those forms of breaking down rocks eventually chips off teeny little pieces of them, and then they collect in a certain place. Beaches and deserts are formed in this way. All that sand is sediment. You can have all different sorts of sediments, little chunks of rock. Anywhere you get teeny tiny chunks of rock, that is sediment. And sometimes that sediment can be formed when water evaporates the minerals that are left behind. Different salts and minerals. Sometimes you can have things that when they die and leave behind their bones, well, those bones end up getting fossilized and turning into rock and then broken down, and that can turn into sediment. Sediment, basically any form of rock breaking down into separate pieces, and when those separate pieces are compacted together, they eventually form sedimentary rocks. There are mainly 3 kinds of sedimentary rocks. Like we said, sediment, chipped off, broken down rock. That's on your worksheet. Just restating that for you. 3 types of sedimentary rocks. I should specify that there are the most common type of rocks are sedimentary. 75% of the rocks in the world are sedimentary rocks. And the 3 types are chemical, clastic, and organic. Chemical, plastic, organic. Chemical sedimentary rocks occur when water evaporates and minerals are left behind. That's the most common type of formation because water is technically a chemical. Well, minerals exist inside those chemicals and other liquids, and when it evaporates, whatever is left behind can sometimes, through enough pressure, can form into rocks. And common types are flint, rock salt, iron ore, and some types of limestone. There's different kinds of limestone, and they're formed in different ways. Some types of limestones are chemical sedimentary rocks. And after that, we have things like clastic sedimentary rocks. These are the most common of the sedimentary rocks. The most common of the most common, in a way. Because like I said, 75% of all the rocks in the world are sedimentary rocks, and a little more than half of all those sedimentary rocks are clastic. This is because when those tiny little pieces of broken rock, like sand or little chips of rock, when they're broken down by weathering and erosion, through cementation and compaction, basically smushing down of those sediments, you end up getting different kinds of rock. Like, think of when you get Rice Krispie treats. Well, they're individual little tiny they're usually individual tiny rice flakes, right? They're little Rice Krispies. Well, when you make Rice Krispie treats, you're smushing them together. You're usually using like marshmallow and butter and stuff, but it's a similar sort of way that they are compacted together to form one thing. I'm hungry now. And the most common types of this, like I said, this is the most common one, and you get things like shale and sandstone. That's right, sandstone, compacted sand. See? Makes sense. And the third kind, and this is my personal favorite because it actually answers questions about the world, is organic. Now, organic ones are when any sort of animal or plant remains, like bones, end up getting when the bones end up fossilized, it can through situations like being covered with soil and being away from all sorts of things, that calcium is replaced with rock. That calcium can usually form other types of limestone. This is a different limestone than the one we said before, because this is formed through a living creature's calcium. Well, sometimes those bones themselves can also become rocks. So you get two different kinds of rocks from the same source, which is pretty cool. You got the limestone, and then you got the fossil. Well, they can also form fossil fuels, like coal and crude oil. That's how you get those. Those are formed from fossils that were buried there eons ago, through a lot of pressure and chemical changes. It's super complicated. I actually wish I had more time to... If we were in a classroom, I'd have so much time to go over this, and we would have so many more examples. I would tell you the exact process that a fossil takes to get to the point where it turns into coal, or fossil fuels, or actual fossils. But the basic idea is that a bone, calcium, stripped away, replaced with rock. This process is called fossilization. The calcium turns into other things like limestone. The fossil is left behind. Sometimes it doesn't get preserved all the way, and it can turn into things like coal or fossil fuels. Because it actually takes a long time and a lot of things to go right for us to actually get fossils, which is why sometimes they're very, very hard to find. Which is why when they actually find, like, an amazing amount of fossils, or an entire creature that's preserved down there in fossil form, they get super excited because it's like, wow, this is rare. Now, the reason that we are super excited about organic fossils and how a lot of these things layer is because rocks actually stack on top of each other when the sediments are layering on top of each other, whether it's through weathering and erosion, through the process of fossilization, whatever it takes. When they stack up together, they're called strata. Strata means layered. Layered upwards. I'm pretty sure you've seen different types of rock formations. They're all in different horizontal bands of colors, and they're beautiful to look at. But what you may not know is they can actually tell time. The layers that are at the bottom are older, the new ones are at the top, and judging by the types of fossils found in those layers, the kinds of rocks they are, how close to the actual ground they are, scientists can tell what happened in the past. In fact, using one of these, scientists have been able to prove one of the theories about why the dinosaurs died out, and that is through something called the KT boundary. The KT boundary is actually a little strata of rock deposits, little strata of sediment that has been compacted into a single line that is mostly consisted of little tiny glass spherules. This glass was created by rock that has been superheated, broken apart, fused back together over and over again. Sulfur, which exists in high temperature, almost volcanic areas, like, a volcano or, say, a meteor strike. That's right. They're proving through this. And along with the KT boundary, they also noticed the presence of a element known as iridium. Iridium doesn't naturally exist on Earth. The reason why it exists there is because it came there from a a meteor. There we go. An asteroid entered the atmosphere, became a meteor, hit the Earth, became a meteorite. It released a whole bunch of ash, dust, and fire that blotted out the sun. Rocks fell to the ground over and over again And they did it so many times, they ended up covering the entire planet. Scientists have looked all across the world, looking at the strata that correspond to the exact same time, and they have found the KT boundary. And thus, they have managed to prove that during this specific time, 65 billion years ago, a meteor impacted the Earth, wiping out most of life. And they did this with sedimentary rocks. That is awesome. Now, what happens when you take a sedimentary rock and step up the pressure? You get a metamorphic rock. We're going to talk about that next week, so stay tuned. Same bat channel, same bat time. Your parents will understand that reference. Anyway, see you guys next week. And as always, I love you 3000.